We had seen item 4. Now we proceed with item 5. Item 5, still on stoichiometry and the other different relations, not necessarily mass. It can be volume, it can be atoms, yeah, not necessarily mass. So for item 5, what do we have? Due to surging demand of gaseous hydrocarbon within both domestic and industrial sectors, the government cleared an investor to establish its production and packaging facility. Recognizing the potential public concern and importance of informed decision making, the government has mandated awareness campaign to educate the public about the hydrocarbon, highlighting its applications basing on the chemical reaction below. So we are given this equation. Stoichiometry will always be given an equation to relate products with reactants. So what is the key task here? The task is to guide the public with the methodology approach to know the amount of hydrocarbon in grams that they would purchase that is required to completely react with 240 decimeters cubed of oxygen gas at STP. Hope you've seen what is given. We are given 240 decimeters cubed of oxygen. 240 decimeters cubed of oxygen. You have to notice what is given. What do we want? Guide the public on the methodology approach to know amount of hydrocarbon in grams. Amount of hydrocarbon in grams. So we have volume of oxygen. We want to determine mass of hydrocarbon. Therefore, you start, as we have seen in the previous item, you summarize your pathway. You start with what you have, that is volume of oxygen. From volume of oxygen, the mind map says that. Now, if you don't know what the mind map is, you have to refer to the previous videos, where we saw how to convert volume to mass. So the mind map will help us convert volume of oxygen to moles of oxygen. Then since we shall be having moles of oxygen, now we shall use the equation to find moles of the hydrocarbon. The hydrocarbon is methane. Hydrocarbons, so you look at the equation, you look out for that element which is made up of carbon and hydrogen. That is what we call the hydrocarbon. And from the given equation, that our compound is CH4. Then from the moles of CH4, we shall find mass of CH4. Then we start with converting volume of oxygen to moles of oxygen. The mind map summarizes what we use. Yeah, summarizes what we use to move from volume to moles. So it says that 1 mole. So you have to look at the information which is in the bracket. Here they have told us that 1 mole of a gas occupies 22.4 decimeters cubed at STP. This is the same as saying that 1 mole is equal to 22.4 decimeters cubed. Now you may ask me, why moles? To move from volume to moles. To move from volume to moles, this is what we use. Yeah, because here I want to move from volume of oxygen to moles of oxygen. So 1 mole is equal to 22.4 decimeters cubed. Now I ask myself, how many moles account for 240 decimeters cubed? Because this is the volume in the question. So to find these moles, we cross multiply. We multiply 240 with 1. Yeah, 240 with 1, then 22.4 with the unknown. So we shall have 240 times 1, then over 22.4. We saw this. We saw how to move from volume to moles. Therefore, number of moles shall be equal to 240 times 1 over 22.4. And this gives 10.7143 moles of oxygen. Then I relate oxygen to CH4. What do we use? In this case, we use the concept of mole ratio. Relate what you have to what you want to find. What do I have? I have oxygen. So we are considering ratio of oxygen to CH4. And from the equation, what does the equation say? How many oxygens do I have? The equation says that you have 2 moles of oxygen and 1 mole of CH4. 2 2 moles of oxygen react with 1 mole of CH4. As a result, what shall we have? We shall have 2 moles to 1 mole. Then what of the 10.7 143? So here we shall have from the previous session we have seen to find the moles here, we shall have 1/2. If 2 moles react with 1 mole, then 10.7143 will react with this 1/2 times 10.7143, and this gives 5.3571 if you calculate it. They are moles of CH4. Now we have moles of CH4. We convert these moles to mass. What do we use in this case? We use number of moles is equal to mass of CH4 over molar mass of CH4. Molar mass, we obtain it in the same way as RFMs. Yeah. So molar mass is just for covalent compounds. RFM is just for ionic compounds. Yeah. So it is, let it not confuse you, same as RFM. So in this case, this is what you have. We substitute. The moles are 5.3571, and these are equal to mass of CH4 over molar mass. So from the information, C carbon is 12. This information is always given that C equals 12, H equals 1. So C is 12. It may not be attached directly to the item, but you check at the front page of the question paper. This information is always there. So C is 12 plus 1 times 4. Yeah, and this case, this is 16. If we sum this up, we obtain 16. Then cross multiplying, this is 16. So we shall have 16. To make mass the subject, we shall have 16 times that. So 16 times 5.3571 gives us 85.7143 grams. Please confirm this multiplication, confirm that multiplication. So this is the first approach. Then the second approach, the technical approach, it arises from the equation. From the equation, you have to interpret the equation. From the equation, we have seen that there are 2 moles. There are 2 moles of what? 2 moles of oxygen and 1 mole of methane. So we shall say 2 moles of oxygen react with 1 mole, because all these things have been on one side. So 2 moles of oxygen react with 1 mole of CH4. Then what do we have? We have volume of oxygen. We have volume of oxygen. Therefore, here we shall relate the moles to volume. Relate the moles to volume. Relate moles to volume. 1 mole is 22.4. 1 mole is 22.4. Therefore, a moment. I think I'm going to continue with this.